Hi everyone. As I said in the previous video, in this video we are going to be doing relational algebra, and I've already mentioned that relational algebra is a more formal language that we use. So let's just talk about the student relation that we had earlier. Let's say I have a student relation with the SID, and I have the name right here, and let's just say I have something else right here, which is let's say the gender. I'm just going to write GEN there, but this is the relation that I have. So the first thing in relational algebra is the simplest expression that we can have, and let's just say that this is the student relation. So the simplest relational algebra that I can write is to just say student. So I just write student. This thing right here is a valid relational algebra query. So all I'm saying is get me the entire student relation. So this is fine, and that's the simplest query that I can have. The next one is an operator that I want to talk about, which is the sigma operator, known as the select operator. So this is known as the select operator, and what this does is that it selects some specific entries from this student relation for me. So what I can say is sigma, and as a subscript of this sigma I write the condition that I want. So let's say I say that gender equals M. So I want only the male students right here, and then I say some uh, expression right here. So what this means is from relation student, select all those entries for which gender is male. So the general syntax for this you can say is sigma, and then a condition right here, a condition, and then an expression. So this need not necessarily even be the name of a relation only. I can have another relational algebra expression right there, and I can use that inside of this. And for the condition, I'd just like to mention at this point that when we do relational algebra, this thing will stand for an equal to. This thing is a greater than, less than. These are just the normal symbols, and similarly we'll have less than or equal to, and greater than or equal to. The symbol to take care of is the not equal to symbol, which is denoted by something like this. So we use the less than and the greater than symbol to say not equal to. So these are the things we can have to mention the conditions. And similarly, when we are talking about some entry in a column or in a cell, we usually put it inside of these uh, inverted commas. So when I wrote gender equals male, I enclosed the M in these inverted commas. If I wanted to say something like name equals Shreyas, I would put that in inverted commas. So that's how we write the conditions. So this is the first operator that I wanted to talk about. The next one is the project operator, denoted by pi. So this is the project operator, and the way this project operator works is that it gives us certain attributes from the column. So like we had the select operator, which selected certain rows, the project operator selects certain columns. So basically what I can say is project name, uh, and here I can have any expression. So let's just say I put the entire student relation here. So that means that I'm going to get something like this, which is just the names. So there'll be one name, the next name, and so on. This will have the names of all students. So this is what this query is going to return. And again, the general syntax is to just say pi and then the names of attributes that we want. So I can have a1 comma a2 and so on, and then here I can give an expression. And once again, this expression can be a complicated relational algebra expression, need not necessarily be a relation only. So next, let's look at how we can write queries with combinations of this project and select operators. So what I can do is, let's say I want the names of all male students. So we are going to exactly combine what we did with the select operator and then what we did with the project operator. So I'm going to say select gender equals male from student, and then from this whole thing just give me the name. So this is how we can write it. And it's actually a much better idea to write it this way, because if we flip the order of the select and project, it won't make too much sense. Let's quickly just look at why it won't make sense. So let's say I do select name from student, and then to this we do select gender equals male. Now the reason this doesn't make too much sense is because what does this inner part give me the result as? It gives me the result as this thing here exactly. So it just gives me this thing. And after that we are trying to say that I want to select those who have uh, gender equals male, but this relation right here doesn't have an attribute called gender at all, because we've already gotten rid of that thing. So that's why this one would be wrong. It's wrong to write it that way. The correct one would be this. So in this case also you can check that we are actually not doing anything illegal. This inner part is going to give me the entire student relation. The only difference would be that I would have lesser rows, but I'm going to have all my attributes right here. And then I'm saying that from these attributes I just want this one attribute called name. So that's what we're doing. So this is the very basics of relational algebra. The next thing we're going to look at is something called a join. So what a join means is sometimes we may want to access data or put conditions on combinations of tables. So how do we do that? We join the two tables, and there are multiple ways to join two tables, and we're just going to look at three of those here. So the first one that we're going to look at is the sorry about that. We are going to look at the Cartesian product or the cross join. So Cartesian product. This is also known as the cross join. So what this means is, let's say I have two tables right here. One is the student table that we looked at in the uh, previous pages, and the next I have something like a professor table, which has, let's say, a professor ID, and then again it has a p name, let's say, and let this be s name for now. so that there's no confusion. And then this might have, let's say, his office number or something. So we have these two relations right here. uh, and what I can do is I can say something like student cross professor. So denoted by a cross is the Cartesian product, and now what this gives me is a large table with 1, 2, 3, 4, 5, 6. So this has SID, this has S name, this has the gender, and now I have the PID, the P name, and the office. So this is the table that I get. So it's basically just taking every entry from the student column and joining it with every entry from the professor table, sorry, the student table, and joining it with every entry from the professor table. So in this, you'll notice that the number of columns that I have is 1, 2, 3, 4, 5, and 6, which is basically, let me just write it here. So the number of rows, sorry, the number of attributes is the sum of attributes of the two tables that I was joining, and the number of rows, you'll probably be able to predict this, but it's equal to the product of number of rows. So if this one had m rows and this one had n rows, then the number of rows in this would be m cross n, and if this one has a attributes and this one has b attributes, then this one has a plus b attributes. So that's how the Cartesian product works. And the next thing that I want to talk about, the next join, is something called the natural join or the equijoin. So natural join. So what the natural join does is that it makes sure that, let's say, I have a common column in both of them. So in this case, I'm going to take a slightly different example. Let's say I have a column, let's say I have a relation called student, which has again SID, S name, and gender. And let's say I have another table which is let's say course. So this one has a course ID, this one has a course ID, there's a student ID for whatever student is registered in this, and then there might be a PID for the professor ID, let's say the professor who's taking this course. So here what I can do is I can say the natural join is denoted by a bow tie, something like this. So what I can do is I can say student natural join um, course course. And what this does is that it makes sure that the SID right here and the SID right here are equal, and it only takes those rows for me. So basically you can think of this thing as being equivalent to saying something like this: select student dot SID equals course dot SID from student cross course. So this thing right here is quite similar to this thing. The only difference would be that when you do a natural join, it gets rid of the duplicate columns. So when I get the result of this thing, it won't have 6 attributes or 6 columns. It would only have 5, because the SID is repeated, so it'll just take the SID once. Whereas when I do a cross join, it'll probably have the SID twice. And one thing that I want to point out at this point is that, let's say I do a cross product here. After that, if I want to refer to SID, I would have to refer to it as student.sid or course.sid, because if I just say SID, it becomes ambiguous as to which SID I'm talking about. Am I talking about the one in the student table or the one in the course table? So that's basically about the natural join. And the third and last join that I want to talk about is the theta join. So this is known as the theta join. And what the theta join means is that we just put a condition, which is theta. Theta is our condition for the join, and we can denote it by something like this, where this theta right here is my condition. So I can just use something like expression 1 and theta join expression 2. So I can just put the condition that I want right here, like I had the condition which in the previous one, which said that the student.sid and the course.sid must be equal. All of that I can put as the condition right here. And one thing to remember is that it puts this condition on the cross join of expression 1 and 2. So condition on cross join on cross join, and not the natural join. So that's basically about the theta join. And all of the joins that we have seen till now are associative. What it means is that if I write expression 1 sum join expression 2, it's the same as writing expression 2 join expression 1. So the cross join that we've seen is associative, the natural join is associative again. So all of the joins that we have seen till now are associative. We'll later be looking at joins which are not associative as well. But before that, there's a few operators that I want to discuss. So there's a few operators that we'll discuss in the next video, and then we'll go on to look at some other kinds of joins. So stay tuned for the next one.